before we continue here, make sure that you know what sec, cosec and cot are, and make sure you can differentiate obviously the trigonometric functions sine, cos and tan. Enjoy the video.
Okay, so now we've looked at using all three rules in the previous videos. We now want to try and differentiate the reciprocal trig functions cosec, sec and cot. So we'll start with cosec because cosec is relatively easy. So cosec x in terms of sine, well the third letter rule will tell us it's 1 over sine x. Now differentiate y equals 1 over sine x, you can differentiate super easily using the quotient rule. So v times that, so sine x times 0, take away u v dash, so take away cosine x all over sine squared x. So you're going to get minus cos on sine squared, and then minus cos on sine squared is the same as minus cosine x over sine x multiplied by 1 over sine x. So we get minus cot x cosec x for number 1. Alright, now if we wanted to differentiate that using the chain rule, certainly can. Easiest way to do that is put that as sine x all to the power of minus 1, and then we could find its derivative using the chain rule. So we've got the minus 1 multiplied by the cosine x, lots of sine x to the minus 2, using the product of powers. Now I can't write that as a positive using our rules of indices, and we get exactly the same answer as we did up here, just using the chain rule. So we're going to use this now to differentiate sec x. So let's try and differentiate sec then. Well, sec x, using our third letter rule knowledge, that'll be 1 over cosine x. And again, you can differentiate using the quotient rule to this. So we've got v u dash, so cosine of x multiplied by 0, take away u v dash. So it's minus 1 times minus sine x, all divided by cos squared x. So minus 1 times minus sine will just give us positive sine x over cos squared x, which I can rewrite that as sine x over cos x, multiplied by 1 over cos x. Sine over cos, we know, is tan, so we get tan x times sec x. So it's tan x sec x or sec x tan x, whichever way you want to write it. And again, I could have differentiated this using our use of the chain rule. So by right of the chain rule, I can differentiate this, so I can find that y prime is the minus 1 coming out the front, multiplied by the minus sine x, derivative of sine and cos, of course, you need to know, of cos x to the minus 2. And then I can rearrange. So I just get sine x over cos squared x. And of course, making sure you put the 2 there and not there, because it looks like cosine of x squared without your brackets, because mathematicians are lazy. That's how we do sec x. Shall we do cot? Might as well do cot while we're at it. So cot x, what is cot using our third letter rule knowledge? Again, that's 1 over tan x. Well, what is tan for a start? Well, if you don't know what the derivative of tan is, that's totally fine, because 1 over tan is the same as cosine x over sine x, using your trig identity. So we can then differentiate it either way. So I could have said y prime is the minus 1 times by sec squared x, lots of tan x to the minus 2, using the chain rule. So I get minus sec squared x over tan squared x. Or, if I was being lazy, I could well have just differentiated it using the quotient rule. So v times that, so tan x times 0, take away that times that, so minus that times sec squared x over the bottom squared, so tan squared x. which is just minus sec squared x over tan squared x. Nice and easy. Alright, and you could differentiate it with cosine over sine, nothing against that, you totally could. In fact, it might be a bit easier, I'll show you how to do it anyway if you're interested. So we get v sine x multiplied by minus cos x, or minus sine x, should I say. I take away the cosine times the sine derivative, which is just cos x, and divided by sine squared x. So we got cosine squared x minus sine squared x. Sine squared x, and we can rearrange as we do. Alright, so that's how we can differentiate the reciprocal trig functions, and next we need to look at parametric differentiation and implicit differentiation.